Hello, in today's lab I will configure trunk links between switch 1 and switch 2 and switch 3, and I will also configure VTP server and VTP clients in the same VTP domain. Also, for the purpose of this lab, I will configure an extended VLAN on one of the switches and assign ports to VLANs, and finally I will verify end-to-end connectivity within the same VLAN. I hope my videos are helpful for those who are seeking to be certified for the Cisco exams. If you like my videos, please subscribe to my channel and share it on your Facebook page and give me the thumb up. And please let me know if you have any suggestions, comments, or questions. I'll gladly answer you back. Also, I have posted all of my videos on my group on Facebook. It's called CCNA Free Practice Labs Walkthrough. Download packet tracers and follow the walkthrough documents on all the labs. On the description of this video, you will find two files, one for the packet tracer source files and the documents to walk you through the lab step by step until you finally will be able to verify the configurations you did during this lab. Now, what is extended VLANs? They are VLANs within the range of 1006 to 4094. They are mainly used in service provider networks to allow the provisioning of number of customers. Extended VLANs are used just like normal VLANs, only different range. Extended VLANs must be configured on switches that are in VTP transparent mode only. You need to know also the normal range VLANs on these switches are numbered 1 to 1005, and extended range VLANs are numbered from 1006 to 4094. Now, what's the difference between VLAN and extended VLANs? VLANs numbered from, as I said, from 1 to 1005 are considered as a standard. VLANs from range of 1006 to 4094 are considered extended VLANs. And the VLANs from 1006 to 4094 can be advertised by VTP, and the switch must be configured in VTP transparent mode, especially if you are using VTP version 1 and 2. Next, I will be configuring VTP. VTP stands for VLAN Trunking Protocol. I will configure all the switches to use VTP for the VLANs updates. On today's lab, switch 2 will be configured as the VTP server. Switch 1 and switch 3 will be configured as the clients. I will configure Academy as a VTP domain, and Cisco would be the password in today's lab. Now I'll start with the switch 2. Enable. Configure terminal, host name SW2. Now VTP domain, as I said, it would be Academy. VTP mode on switch 2, we want this to be the server. And as for the password, we said we want it to be Cisco for today's lab. Next, I will do switch 1. Host name SW1, VTP domain Academy, and VTP mode on switch 1. We want it today to be a client, and for the password, just like how we configured it on switch 2 of Cisco. On switch 3, we'll do the same. VTP domain of Academy, VTP mode on switch 3 of client, and as for the password, just like we did on switch 1 and 2 of Cisco. Next, I will verify the configurations by using the show command, show VTP status on the switches. I'll exit from here. This is switch 3. Show VTP status. As you can see here, it's showing that we are using VTP version 2 and the revision is still nothing. We can have up to 255 VLANs on this local switch. Number of existing VLANs are 5. We configured switch 3 as a client on the domain of Academy. Where did we get this number 5 of VLANs on switch 3? This is by default. Show VLAN brief. We have VLAN 1 and VLAN 1002, 1003, 1004, 1005. There are 5 VLANs. This is how we got this number here. Now I'll do the same on switch 1. Exit. Show VLAN VTP status. Switch 1, we also configured it as a client in Academy. This is our domain name, VTP domain name, and number of existing VLANs, the built-in or the default VLANs, and revision 0 and version 2. And on switch 2, show VTP status. Sorry about that, show VTP status. We configured switch 2. This is our VTP server. Now I will configure DTP. DTP stands for Dynamic Trunking Protocol. I will configure dynamic trunk links between switch 1 and switch 2. First, I will run the show command on switch 1 and switch 2. So I'll start with switch 1 here. The show command is show interface F01, the link between switch 1 and switch 2, switch port. This is our show command on switch 1, showing us that the name on the port of F01, switch port is enabled, administrative mode is dynamic auto, operational mode is static access. Now I'll run the command on the other side of the link on switch 2. Show interface on F01 switch port. The same here. We are checking this port. Switch port is enabled. The administrative mode is dynamic auto, and the operational mode is still static access. Now, we notice the administrative mode is configured to dynamic auto, and the operational mode is static access. Now, what is administrative? Administrative mode is what's configured on the switch port, like to negotiate trunking. Operational mode is the actual status, result of interaction with the device connected to the port, like a trunk with ISL or 802.1q encapsulation. And now, what does dynamic auto mean? As we saw here, what does this mean here? Dynamic auto. This means switch port mode dynamic auto makes the interface able to convert the link to a trunk link. The interface becomes a trunk interface if the neighboring interface is set to trunk or desirable mode. The default switch port mode for newer Cisco switch Ethernet interfaces is dynamic auto. Operational mode equal static access. This means the port is an access port and not a trunk port. Operational mode means static access. This means that the port is an access port and not a trunk port. Administrative mode dynamic auto, this is for DTP negotiation, which means in this mode, if this port is connected to another switch and both sides are configured as dynamic auto, the port will never become a trunk. I will configure dynamic trunk between switch 1 and switch 2 because the default mode is dynamic auto, and only one side of the links needs to be configured as dynamic desirable because the other side is dynamic auto. Now on switch 1, on this guy here, I want to configure the link between switch 1 and switch 2. Excuse me. Configure terminal on the interface of F01, switch port mode dynamic desirable. Enter. We configured this as dynamic desirable, and this side here is auto, dynamic auto. Now, I will verify the trunking link between switch 1 and switch 2 using the show command show interface trunk. Now, I will run this command here and show interface trunk. I want to point something here. What does this mean, the N? What does the N mean in N-802.1q? It means it negotiated the trunking encapsulation type because it was not explicitly set in the config. If you actually put the switch port trunk encapsulation.1q on the switch port, that N will disappear. When using desirable to set a trunk, it will negotiate on its own. This is what the N here means. It's all, everything here, I explained it in the, they are written there in the walkthrough documents. Now let's continue. On switch 1, I run this command show interface trunk. Notice here the mode desirable. Here it's desirable. What do you expect it will be here when I run this command show interface trunk here? Let's see. Show interface trunk. It was desirable on switch 1, and here it is set to auto. Dynamic. Next, here the operational mode on switch 1. Here, as you notice, as we said, desirable, dynamic desirable. And the operational mode trunk, which means this port is operating as a trunk, not access or dynamic. Now I will run this show command on switch 2, show interface F01 switch port. Notice the administrative mode here. The administrative mode on switch 2, operational mode is a trunk, and the administrative mode is dynamic auto. But on switch 1 here, if I run the command show interface F01 switch port, here it's showing we configured it as desirable. On switch 2 as I will configure a static trunk link between switch 1 and switch 3 on this port here. I will use the switch port mode trunk command in the interface configuration mode for port F03. Now on switch 1, configure terminal interface F03, switch port mode trunk, just simple like that. I will verify the trunk on switch 1. I will run this command. I'll exit from here, another exit, show interface trunk. Notice the mode on F03. This is between switch 1 and 3. And it is trunking. But if I ask you this question, why do we have the N here? Just get back in the video and read the explanation why we have it N and what does it mean, the N. Now, I will verify on switch 3. Enable show interface trunk, and we configured here as trunk. Here it is still set to auto and negotiated. This is a trunk, which means it will negotiate it to be both as a trunk link between switch 3 and switch 1. Next, the trunk links are required to pass VLAN information between switches on the network. Switch port trunk means when you have a trunk link, all VLANs are allowed to pass through a trunk link. Now I will configure a permanent trunk link between switch 2 and switch 3, which means I need to configure both ports on switch 2 and switch 3 as static trunk. So we are on switch 3, configure terminal. On the interface here on switch 3, interface connected to switch 1, which is on F01. Switch port mode trunk, enter. Now on switch 2, I'll do the same. Configure terminal, interface F03. Switch 2 connected to switch 3 on F03. Interface F03. Switch port mode. Next, I will add VLANs and assign ports. I will try to add VLAN 10 to switch 1. Now, switch 1, we configured it as show VTP status is as a client, as you can see here. Now, I will try to add VLAN 10 on switch 1. Configure terminal VLAN 10. Enter. Now, we receive this message on the switch here saying that VTP VLAN configuration not allowed when device in client mode. You can never add a VLAN when the switch is in client mode. Now, VLAN trunking protocol VTP client mode switches listen to VTP advertisement from other switches and modify their VLAN configurations accordingly. A network switch in VTP client mode requires a server switch to inform it about the VLAN changes. We cannot create, add, or delete VLANs in a VTP client. Now we have VTP2 as our server. I will run this command, show VTP status. And our switch 2 is the server, the VTP server. I will add the following VLANs: VLAN 10, name users; VLAN 20, name admins; VLAN 30, guest; and 99, the management VLAN. Configure terminal, VLAN 10, name users; VLAN 20, name admins; VLAN 30, guests; and VLAN 99, and this will be our management VLAN. Now let's check what we did so far on switch 2. I will verify and run this show command on switch 2. And here, show VLAN brief. Those are the 4 VLANs we created. Now I will verify VTP updates on switch 1 and switch 3. And because I configured switch 2 as VTP server and switch 1 and switch 3 are configured as VTP clients, now switch 1 and switch 3 should learn and implement the VLAN configure information from the VTP server, which is in our example here is switch 2. So on switch 1, show VTP status. Notice now the VLANs, the configuration revision are 8 and the number of existing VLAN are 9. And I will run this command. We did not configure anything on switch 1, but if I run this command, show VLAN or VLAN brief, and it is showing us the VLAN which we configured on the VTP server with the names on switch 1. And switch 1 is the client. Now on switch 3, I'll run the same commands, show VTP status, 9 VLANs, 5 by default, and the 4 which I configured on switch 2, the server. Now they are 9, and the configuration revision are 8, and we have our the operating mode on switch 3. It has a client. If I run the command show VLAN or show VLAN brief, and it's showing us the 4 VLANs which I configured on switch 2, which is our server. Next, I will assign port to VLANs, and I will configure IP addresses as it's showing on the topology. On switch 1, here I will configure port, or I'll configure F06 as access port VLAN 10. On switch 1, configure terminal interface F06. F06, the port connecting our PCA, switch port mode access, switch port access VLAN 10. This is how we configured for VLAN 10. Now on switch 2, we have port F18 and VLAN 20. Global configuration mode, interface F18, switch port mode access, switch port access VLAN 20. And on switch 3, we have this port F18, and this is in VLAN 10, just like with on switch 1. Global configuration mode, interface F018, switch port mode access, switch port access VLAN 10. Now, I have already configured the PCs. We have here PCA with the IP addresses, PCA within the VLAN 10, PC2, VLAN 20, and C, and I configured the IP address. Now I will configure IP address on the switches. On switch 1, switch 2, and switch 3, I will assign an IP address to the SVI, which stands for Switched Virtual Interface for VLAN 99, as it's showing on the topology. Now, what is SVI? A Switched Virtual Interface is a virtual interface and port that transmits only untagged VLAN packets for managed switch. There is one-to-one mapping between a VLAN and SVI. Thus, only a single SVI can be mapped to a VLAN. Allow traffic to be routed between VLANs by providing a default gateway for the VLAN. Now on switch 1, we have this IP address for VLAN 99. I'm here as it's showing, I am in the interface configuration. So I can enter VLAN 99 on switch 1. And this is, as you see or notice, the minute I type the interface into the configuration of the VLAN 99, it brought the port, the SPI port up. And this is with the IP address of 172.16.99.1/24 subnet mask. And even though the port is open, I'll just reactivate it with the no shut command. Now on switch 2, I'm in interface configuration mode, interface of VLAN 99, and this is with the IP address of 172.16.99.2/24 subnet mask. And on switch 3, interface of VLAN 99, and this is with the IP address of 172.16.99.3/24 subnet mask, and activate the port with a no shut. Now I will verify connectivity. I will ping PCA from PCB. So I'll jump into PCB. And here on the command prompt, ping 172.16.10.10, and this ping should not be successful. Why? Because we have PCB in VLAN 20 and PCA in VLAN 10. They are not in the same VLAN and not in the same network. So I will ping PCA from PCC. Go to PCC. And from here, ping 172.16.10.10. What do you expect when we ping? Remember that now PCC is in VLAN 10 and PCA also in VLAN 10. They are in the same VLAN and they are in the same network. So when I hit enter, it should be successful. Now I will ping switch on switch 1, or I'll ping PCA from switch 1. I will ping PCA from switch 1. Now the question is, switch 1 we configured in VLAN what? 99. Switch A is configured within VLAN what? 10. So they are in a different VLAN, 172.16.99.1, 172.16.10.10. So let's see. Go to switch 1 and ping PCA 172.16.10.10, enter. And it should fail. Why? Because they are in different VLANs and they are in different networks. Now I will ping switch 1 from switch 2. I'll ping switch 1 here from switch 2. Both switches are in VLAN what? 99. So do you think the ping will be successful? It should. Why? Because they are in the same network. Ping 172.16.99.1, and it should be successful. And it is. Run it again, and it went through. Now try on your own when you reach this point, ping from switch 3 to switch 2, and it should be successful because both are in the same network and the same VLAN. And from ping PCA switch 1 from switch 3, and ping switch PCA from PCB from, just run your commands, the ping commands, and see how it goes with you. Now it's time to configure extended VLAN. As we said, extended VLAN is a VLAN between VLAN number 1006 and 4096. And because the extended VLANs cannot be managed with VTP, VTP must be configured in the transparent mode. I will change the VTP mode on switch 1 from server to transparent and create an extended VLAN on switch 1. So we have switch 1, show VTP status. Switch 1 is a client. I will change this from a client to a transparent. Configure terminal, VTP mode, transparent, exit, show VTP status. Let's double check. And as you can see here, it is in transparent mode. Now I will run the command show VLAN brief. We have these VLANs are configured in switch 1. Now I will create an extended VLAN, VLAN 2000. Now configure terminal, VLAN 2000, enter. And I will verify that this is okay. Show VLAN brief. And here we go. This is our VLAN I just created. Now, on switch 3, I will try to create VLAN 2000. Exit from here. And I'll exit from here to show VTP status on switch 3. It's a client. Now, let's see if we can create a VLAN on a VLAN 2000, an extended VLAN on a switch in VTP client mode. Configure terminal, VTP, first I'll try to create the VLAN 2000, and VTP VLAN configuration not allowed when device in client mode. But now if I change it, VTP mode into transparent, and now try to configure add VLAN 2000 and exit from here, another exit, show VLAN brief, and here we go. We were able to configure a VLAN on the switch after we changed the VTP mode from client to transparent. Thank you so much for watching. I appreciate if you will send me any comments, any suggestions, email me, text me, write a comment. And if you like this video, please subscribe to my channel, tell your friends about it. Thank you so much, and I'll see you soon in my next video.